Hey everyone, so this is our second video in the blog series Ichigai and his quest for Zen. So in this video we will talk about this backend front-end parallel development with OpenAPI. So let's jump right in. So let's discuss the problem first. Suppose you are given a task where you have to work with some front-end guy, and the front end could be anything. It could be Android, it could be web client or anything. So the first thing that you will do is you will define the contract. So you have to know first, right, how you guys are going to talk to each other. So normally how we do it is we create a JSON file and we give the structure. Suppose name is Akshit, uh, amount is uh, amount could be some 20.0, or could be, let's say, 20. Now what's the problem here? First of all, and you will send this file in your Slack or normal messaging group. If you were to work in Promi, this is how you will do it. But what's the problem here? First is that I can't write any description or anything here. So JSON doesn't support comments or anything, so I can't write this kind of thing. So this becomes a problem. So if I want to tell someone that, hey, this amount is it in paise or is it in rupee, I can't do it. Another is the when you share the contract in this way, it's not type strict. So you can't say is it a float, is it a double, is it a int. So when you share the contracts this way, it becomes a very problematic. Now the major problems, this might be a small problem, but the major problem is that once you define the contract in this way, you have to write the client again, you have to write the server code again, you have to define the models again. So we are doing a lot of repetitive work. So to mitigate all these problems, we will look at something what is called OpenAPI. So you define the contracts not just between front end and back end, but even between two services who are using REST and JSON for communication. So the all these benefits of auto generation of server interface, auto generation of clients, all this you will enjoy in backend server communication also. So let's look how the contracts are defined, right? So let's go to our OpenAPI server. So what we will do first is that we'll define the contracts. Now note that this contract is not tied to a Java project or anything. It is language agnostic. We write it in YAML file, but you can define this contract independently of any project, any file, any language. So what you will do, you will create one file. So let's look at example of how a contract looks like. So you will define the path slash hello alive. This is your path param name, and this is the get call. So you can put all summary and everything here. So what this call does, then you will do you will put parameters. So what the request looks like and what the response looks like. So you can note that you can write description comments everywhere, and all of this is very type strict. So when you say that name is a path param, you do specify that the schema is set of type string. So yes, you define the types of everything or every request, response, everything. So let's look at the post call also, right? This is not just for primitive data types like string, you can define objects also here. So this is a post call where you give your name and it will give you the greetings. So if you look at it, it's a schemas of JSON type, and the response is of greetings type. So let's go to the greeter. So this one is of type object, and it contains only one field with name and type string. So similarly is the reply for greetings. So once you define this contract, right, it's an independent file. Let's see what you do with it. Once you have defined this contract, what we normally do is that in our documentation page we push it to our version control and we put the link here. So your front end guy can start working parallelly as you start working on the back end. Now he wants to view this contract. He doesn't want to read all this code, right? So what do we do is there are a couple of options. One option is that there is a very nice web portal of editor.swagger.io. So you copy your contract, you paste it here, and it's populated. So note that without even writing the Spring Boot application, you have gotten this entire entire web UI for the contract viewing. And then you can since everything is tightly strictly typed, so you can look at the schema also. You can look at the description, say your name, then schema. So it becomes very manageable this way. Now once you are done with this, okay, another option was the Visual Studio Code. You can use the same, you can view the same contract in Visual Studio Code. So what you would do is like, let's copy the path and use the CLI to open the Visual Studio Code this way. So your contract is here. Now let's try to preview it, because you will want to edit this contract, and there are a couple of plugins. I will link it in the blog post also. So you will preview it in Swagger UI, so you don't have to open the web portal all the time. Whenever you do make some changes here, it will be here, it will be reflected parallelly. So let's see one example. The greeter has name, so let's add another field here. Let's add another field, amount, type integer, and format. Now note we can write in 32, 64, anything. So you can write enums and all also here. Now see the reflection has already been done. So even if you are evolving your contracts, you can push it to your version control system, and you can change the version also, the contract version here, based on your contract has changed backward compatible way, or it's breaking your backward compatibility. So once you push it to your version control, your front end can view that contract. So the communication becomes very easy. So let's remove this change here, and now let's jump to the interface generation part. So once you have defined this contract, you don't want to again write the model class for this, the path, the controller part, everything for this. So you want these codes to be auto generated. So what will you do is that you will use this OpenApi generator plugin, OpenApi generate, and you will specify the output directory where is your greeting api.eml. And the simple thing you will do is that let's run this task. So what will you do? cd order service dot slash gradle w okay, sorry, cd open api server dot slash gradle w, and let's look at the task first, right? Gradle w tasks. So see, we can see that our task has been listed here. Let's generate the file, gradle w OpenApi generate. So you can see now the code has been generated here. We don't have to go inside it, but let's look how does it looks. So there is an API, hello API has been generated, the models have been generated, the greeter, greeting, all these classes have been auto generated. Now the thing that we have to do is just in our greeting controller, we will implement this hello API. This is the auto generated class, and we will just override the method. So suppose if I have already written the code, but if you were to write this code, you would just do Control O. Okay, let me open my KeyMaster also. And what will you do is that you will just do Control O, override. So you can see your is alive. You just write it here and you put your business logic here. So all the grunt work of writing the model class, API endpoints, all that has been removed now. So if we were to write it in this received greetings also, right, since it has a class structure, let's look at it. Control O, receive greetings, and we will build our message here. So you will just write return greetings dot builder dot reply for things like this here. So it becomes very easy. Now once our server has been written, let's first run it and see if it works or not. So what we'll do is let's test our server independently. Gradle w boot run. So now we can see our server is up at 9000 port. So let's open it. 9000. So you can see our server is up and running here, and let's try to run the server. Try it out. Greeting, name Akshit, and let's execute. So we can see that we got the reply in the format in which our class was, right? So that is the server part. Now what we want to do is that we want to generate the client also, be it Java client, be it JavaScript client. So there are a couple of ways. Let's first generate a JavaScript client, because our web frontend will use the JavaScript file, and another service will use the Java client. So let's go to a commands sh file, and this is the command line for generating a Java client. So if you let's paste it, Control C. So what we are doing is here we are using the Swagger code gen. We are doing the generate input file, the language JavaScript. You can specify a lot of languages here, and the output directory. Where do you want to generate this client? So let's execute this. So the client has been auto generated. Now let's try to look at temp test. Now if you will look at this file, right, readme package.json, everything has been created. If you and how to use it now, the using is as simple as that, calling a method call api.isalive. So if you look at the source, all the models APIs have been generated. So this is the JavaScript command line way. Another is the plugin way. So let's generate one client, Java client, for use by another microservice. So how would we do this is that we will add one more task here, build Java client, and it will generate the Java client. We have said that use the generator Java. You could use a generator named JavaScript also, like what we had done in the command line. So what it will do is that it will build the Java client, and we want to publish this as a library to our local repository, or you publish it to your remote repository. This publishing to a remote repository we will cover in another module, which is this one, share your library among yourself code artifact. But till now let's publish it to our local thing, right? So let's go to our Gradle w publish Java client to local. So what it will do is that it will create a jar, it will publish it to a local Maven repository for the client. Let's look if it has been generated or not. m2 repository com Akshit and greeter client. If you can see, you have a version library generated for this entire client. So once you have generated this client, how do we use it? So I have created one another repo, OpenApi client, and in this we have something called build.gradle, and in build.gradle note that I have not included anything related to OpenAPI. For my client, it only matters that just give me a client and I will use it. Doesn't matter what language you are using. So I just add a dependency like this, implementation Akshit greeter client. This is the version, and we just once we have added this dependency, we can build it, and it will recognize this dependency. Now how do we use this client? For using this client is as easy as defining a variable default API greeter client, and we construct this client from this auto generated code. So this default API is our auto generated code from importing that library, and we are set on base path. You will have to specify the endpoint, right, where your server has been hosted. And now using this API becomes as simple as RPC call. So you say that this is your greeter client, so you use like greeter client dot receive greetings, and you can use the response however you like. So I have written these two schedule task, which will first it will check for alive on every 1 second, and second will check for alive every one, say hi for every, and try to receive the greeting every 1 second. So let's try to run both of them, right? So let's start our server first. Gradle w boot run. Now server is up. Now in another window, let's see, run our greeter client, OpenApi client, and let's do gradle w boot run. So if you look at it, it's sending a request to the server, is exit alive or not, yes or no, and another is the post call for greeting, so it's making the get and post call. So yeah, everything works fine. Happy the demo, when the demo works, it's a good day. So these were the things I wanted to touch upon. So what we have covered is that, first of all, how to do parallel development of front end and back end, how to generate API clients from command line, how to generate the API models, the paths, everything on the server side as an interface, and how to generate from the Gradle plugin API client for use by other microservices. So I hope these things were useful to you. Okay, bye, see you in next video.